Good evening, everyone. Welcome to our this week's live session. So, for this week, we start with the problems related to solving differential equations, and let's move to our first problem. Okay, so here we have a differential equation, and we have to tell about what is this degree or order of this differential equation, or if it is linear or non-linear. Okay, so what is the order of a differential equation? So the order of the differential equation is the order of the highest derivative which occurs in this differential equation. Okay, so there are two derivatives. So one is this is order second order derivative, and this is the third order derivative. So the order of this differential equation is 3. So this one is correct answer. Now the degree of a differential equation is the power of the highest order derivative involved. So the highest order derivative is this, and its power is 1, right? This power is 1. So therefore its degree is 1. Okay, so this option is incorrect. Okay, so in a linear differential equation, the dependent variable, which is here y, and its all derivative, they appears with a degree 1. Okay, but here we can see that this second order derivative of y appears with a degree 3. So this cannot be a linear differential equation. So this must be wrong. And so last option is correct. So here first and last options are correct. So let's move to the second problem. Okay. So in this problem, a family of curves is given. So this is a family of curves. Okay. So, and why it's a family of curves? Because here two parameters are involved, a and b. So if you change this parameter a and b, then you will get different curves. So this is a family of curves and contains two arbitrary parameters or arbitrary constants, and we have to find out a differential equation with satisfied by curves of these families. Okay, so that by that we mean that we have to find a differential equation whose solution is given by this equation. Okay, so for that, what we do, we differentiate, because there are two derivatives in this equation. There are two arbitrary constant in this equation. So we will differentiate this equation two times, and then we will try to remove all these arbitrary constant to get our equation. Okay, so if you differentiate it first time, okay, so what is the derivative of the left hand side? We are treating y as dependent variable with an x as independent variable. So if you differentiate the left hand side, then you'll get y plus xy prime is equal to a e to the power x minus b e to the power minus x and plus 2x. So let's differentiate it one more time, then you will get this is y prime, this is x double y prime plus y prime, which will be equal to a e to the power x plus b e to the power minus x and plus 2. Okay, now from this equation, this first equation, we will extract this particular term, because this particular terms appear in this equation, and we will put it equal to xy minus x square. Okay, so imply that this is equal to xy minus x square plus 2. So the differential equation which we are looking for is xy double prime plus 2 times y prime minus xy is equal to 2 minus x square. Okay, so this is the correct solution. So this is the differential equation whose solution is given by the equation first. Okay, therefore the correct answer here is B. Okay, so let's move to the next problem. Okay, in this problem we have to solve we have to find the solution of the given ordinary differential equation. So that differential equation is this. Okay, let's find the solution of this equation. This is dy by dx is equal to x in bracket 1 plus twice logarithm of x divided by sin y plus y cos y. Okay, now you can see that the numerator is a function of x and the denominator is a function of y. So this is a separable type of differential equation. That is, we can separate the variable, just keep all the derivatives of y on one side. So this I can write dy equal to x times 1 plus twice of log x dx. Okay, now we have to integrate both sides and put a constant. So after integrating this after integrating these two functions, we will get the solution of our differential equation. Okay, so note that this left hand side of this equation, this we can write as d of y sin y, right? Y. Okay, so what is d of y sin y? Okay, you have to apply the product rule. So it's y cos y plus sin y, right? And the second term, this x times 1 plus 2 ln x, that can be written as d of x square ln x. Why? Let's write d of x square ln x. Okay, apply the product rule. So differentiate x square, which is 2x, then ln x, plus differentiate logarithm of x, then you will have to divide it by x, and then this will turn out to be x plus 2x log x, which is same as take x common in bracket, you have 1 plus 2 log x, right? So we can write this equation like this. And now this will just imply that if you integrate d of y sin y, that is, it is just y sin y, and here you will have x square log x plus constant. So this is our this solution of this differential equation. Okay, let's not write in the bracket. Okay, so correct option is C. Okay, so here this sign of this constant doesn't matter if it is plus or minus. That's not our concern. We can replace this constant by negative of this, so it doesn't matter. Instead of this, we can write minus of C because it's just a constant. The constant can be replaced by minus C. Okay, so let's move to the next problem. Again, a differential equation is given. So this is our differential equation, and we have to solve this equation and find out which options are correct. So here, all these options are these three options are related to the solution of this differential equation. But the first option asks if the ODE is linear. Okay, so this ODE is not linear. Why? Because here you can see that this involves square. We are taking a square of this particular function 4x plus y plus 1. Okay, so because y is there, so this will, if you open up this square, then you will get a term related to y square. Okay, so that means the dependent variable coming as a degree 2, it has a degree 2 in this equation, so it cannot be linear. So this option is already false. And let's try to solve this equation. So here we have dy by dx is equal to 4x plus y plus 1 whole square. Okay, so what we will do, we just take this 4x plus y plus 1 as some dependent variable w. Okay, so if you differentiate it with respect to x, then we'll have 4 plus dy by dx is equal to dw by dx, and that will give us that dy by dx is equal to dw by dx minus 4. Okay, so we can write this given differential equation in terms of this new dependent variable. So instead of dy by dx, we have dw by dx minus 4, and this is equal to w square. So this will become dw by dx is equal to w square plus 4. So this is again a equation of separable type. So we take all the functions, all the terms involving w one side and integrate plus a constant. Okay, so if you integrate this w square plus 4, then what we will have half of tan inverse w by 2 is equal to x plus c. This will give us that w is equal to twice of tan of 2x plus c. So this is our general solution. Okay, so this we call general solution. Okay, so here now instead of w, we can now put our original function, which is 4x plus y plus 1. So we have 4x plus y plus 1 is equal to twice of tan of 2x plus constant. Okay, so you can see that the second option is also incorrect because this is not the general solution. Now we have to check about c and d. So in this of these two options, a particular value is given that the dependent variable takes value 1 or minus 1 at origin at x equal to 0, and then we have to find the value of the arbitrary constant c and then find what is the particular solution. So we'll check them one by one. Let's put y x equal to 0 and y equal to 1 and minus 1. Okay, so for y0 is equal to 1, we have, so you can see that if you put x equal to 0 and y equal to minus 1, then you have 2 is equal to 2 tan of c, right? So this will just imply that tan of c is equal to 1, and that will give you c must be pi over 4. That means the solution in this condition becomes 4x plus y equal to 1, 2 tan of 2x plus pi by 4. Okay, and when y is minus 1 at x equal to 0, in this case we have again y is minus 1, so on the left hand side we have 0. So 0 is same as twice tan of c. So this will just imply that c is 0. So in this case the particular solution is 4x plus y plus 1 is equal to twice of tan of 2x. Okay, so here we can see that the last option is also incorrect and the correct option is c. Okay, so this is the correct solution. Okay, so should we move to the next problem? Okay, let's move to the next problem. Again, a differential equation is given in this form. Okay, so this and we have to find its solution. So what is our equation, differential equation? It's y square minus 2xy dx is equal to x square minus 2xy dy. Okay, so we will just write this equation in the form of mdx plus ndy is equal to 0. So we'll take this right hand side term on the left hand side. So which is same as y square minus 2xy dx plus 2xy minus x square dy is equal to 0. Okay, so let's call this function as m and this function as n. So m is equal to y square minus 2xy and n is equal to 2xy minus x square. Okay, so first we have to check if this differential equation is exact or not. So what do we mean by the differential equation is exact? So that means that if this particular this left hand side part just becomes, so equation is called exact if the left hand side part mdx plus ndy is the differential of some function fxy. Okay, so if that happens, then we can easily solve this equation. Why? Because mdx plus ndy is 0, and this will just give us that df is 0. So the solution will be f is equal to constant. Okay. So for that we have a check. We have a test to check if this differential equation is exact or not. For that we have to check if these partial derivatives. So if you differentiate m with respect to x, del m over del x is same as del n over del y or not. It's actually del m over del y is equal to del n over del x. Okay, so we have to check if these two are equal or not. So this is our check. To check. Okay, so what is del m del y? So differentiate m with respect to y, we'll have 2y minus 2x. Now differentiate n with respect to x. So we'll again have 2y minus 2x. Okay. So you can see that since del m over del y is same as del n over del x, the given differential equation is exact. So let's write it differential equation 1. So 1 is exact. Okay. Now let's solve this differential equation. Okay. Uh, so what we'll do, let's first write this y square minus 2xy dx is equal to x square minus 2xy dy. Okay, so this is same as y square dx plus 2xy dy. So we are writing this particular part on one side. We are taking 2xy dy on the left hand side and x square dy plus 2xy dx on the right hand side. Okay. Why we are doing it? Because this differential equation is exact, and you can see that the left hand side just become d of xy square, and the right hand side becomes d of x square y. Why? You can check it. What is d of xy square? So first differentiate with respect to x, you will have y square dx and differentiate with respect to y, you will have 2xy dy. Okay, so which is left hand side, and what is d of x square y is 2xy dx plus x squared dy. Okay, so if we integrate both sides, then we have x square y is equal to x plus constant. So this is our general solution of this differential equation, which we can alternatively write as take x common. In the bracket, we have y square minus xy equal to constant. So this is the final solution. Okay, so this option D is correct here. Okay, so let's move to the next problem. Okay, so again, this differential equation is given. So this is our differential equation, and we have to find if this differential equation. So what is the general solution of this differential equation? Okay, so note that a general solution always contain a arbitrary constant. Okay, so but this equation does not contain any arbitrary constant. So this cannot be a general solution, but it may be a particular solution that we don't know. First, we have to solve this differential equation, but from here it is clear that this whatever the given function here is, it cannot be a general solution at least. So this statement is must be false. So correct answer is A. But let's find out what is its general solution. Okay. So first let's check if this is differential equation is exact or not. So let's say this is M and this is N. So what is so we have so let's apply the test. So find partial derivative of M with respect to Y. What is that? It is e to the power x cos y minus e to the power minus y. What is del n over del x? Again, e to the power x cos y and minus e to the power minus y. Okay, so this means that the difference given differential equation is exact. Okay, so let's call it the equation one. So again, since del m over del y is same as del n over del x, one is exact. Okay, so let's find its solution. We have m dx plus n dy. So this can be written as, so we will just rearrange these terms. So we will take these exponential on one side, e to the power x sin y dx plus e to the power x cos y dy, okay, and plus e to the power minus y dx minus x times e to the power minus y dy. This is equal to 0. Okay, now you can see that this particular term become d of e to the power x sin y, and the second term just become d of x e to the power minus y equal to 0. So when you integrate this, this will just become the general solution here is e to the power x sin y plus x e to the power minus y is equal to constant. So this is the general solution. Why? So this is general solution. It contains an arbitrary constant. That arbitrary constant is 3. And we can see that this equation is not even a particular solution, right? Okay, so let's move to the next problem. Okay, so here we have to find the integrating factor of this given differential equation. Okay, so what is an integrating factor? So if a given differential equation is not exact, and if we multiply the given differential equation by some function so that it becomes exact, then that function we call it integrating factor. Okay, so you can see that here, this is your, let's call this as m. So we will write it in terms of m dx plus n dy is equal to 0. Okay, so if you write it in this term, then what is your m? Notice that m is x square y minus 2xy square. What is n? Is 3x square y minus x cube. Okay, so let's see if this differential equation is exact or not. So del m over del y, what is that? It is x square minus 4xy. What is del n over del x? This is 6xy minus 3x square. Okay, you can see that these are not equal. Okay, since del m over del y is not equal to del n over del x, let's call this equation 1. 1 is not exact. But notice that the function m and n are homogeneous functions. Okay, so m and n are homogeneous functions. Okay, therefore the differential equation is also homogeneous. So 1 is a homogeneous differential equation. Okay, so for a homogeneous differential equation, the integrating factor is given by 1 over mx plus ny. Okay, so let's find out what is 1 over mx plus ny. This is 1 over. So what is mx? So if you multiply m by x, then you will have x cube y minus 2x square y square, and plus multiply n by y, then you will have 3x square y square minus yx cube. Now you can see that this x cube y term just cancel with each other, and at the end the limit we get that x square y square. Okay, so 1 over x square plus y square is the integrating factor of the given differential equation. So correct option here is D. Okay, so so one thing is note that here this m and n were homogeneous functions, and why they were homogeneous? Because if you multiply these terms by lambda, let's say lambda x and lambda y, and what is m of lambda x comma lambda y? You can see that you can take out lambda cube common, and it will just become m of x comma y. Okay, so and similarly n of lambda x comma lambda y is equal to lambda cube and xy. Okay, so both m and n are homogeneous functions of degree 3, and because they have the same degree, and that's why the differential equation is homogeneous. So m and n are homogeneous functions of same degree, so that is also important. The degree must be same. Okay, so let's move to the next problem. It is the eighth problem. Okay, so here we have to find the general solution of this differential equation. Again, here this equation, if you write it in terms of mdx plus ndy, okay, yes, what is our differential equation? Is 2xy plus e to power x by dy plus minus of e to power x dy is equal to 0. Okay, so here we have m as 2xy plus e to power x and n is equal to minus of e to power x. Okay, let's check if differential equation is exact or not. So del m over del y is equal to, okay, so what is del m over del y? Because you can see that this y is also there outside of this bracket. So here we have y also. Okay, that means this is actually equal to 2x y square plus y times e to power x. Okay, so if you differentiate, then you will have 4xy plus e to power x. And what is del n over del x? The same as e to power minus of e to power x. Now you can see that because these two are not equal, so let's write it as equation 1. Since del m over del y is not equal to del n over del x, this 1 is not exact. Okay, so to solve this differential equation, we have to find its integrating factor. Okay, so let's calculate this term. What is del n over del x minus del m over del y? Okay, and then we divide it by 1 over m. So this is equal to 1 over m. And what is this difference? If you subtract this, you can see that this is just minus of twice of e to the power x minus 4xy. Okay, and that is just equal to, so what is it? You can take minus 2 common, and then this will just become, m by y. Okay, so you can see that e to power x plus 2xy, this e to power x plus 2xy is just m divided by y, and then we have m in the denominator. So this quantity turns out to be minus 2 divided by y. Okay, so because this quantity is independent of x, the integrating factor can be find out by, so in this case the integrating factor if is equal to the e to the power integral of minus 2y dy. Okay, so what is that? We'll have e to the power minus of ln y square, and which is equal to 1 over y square. This is the integrating factor. So if we multiply the equation 1 by 1 over y square integrating factor, then the equation becomes exact. So let's multiply the equation 1 by 1 over y square. And if you do that, then, so what do we get in that? If we divide by y square the equation 1, so divide or multiply. Multiply equation 1 by 1 over y square to get 2x dx plus e to power x divided by y dy minus e to power x divided by y square dy is equal to 0. Okay, you can see that this particular, the first term 2x dx just become d of x square, right? D of x square is 2x plus 2x dx. Okay, now this the whole thing just become d of e to power x divided by y, okay, is equal to 0. Why? Okay, so if you differentiate e to power x divided by y, if you find its differential, then you can see that it exactly turns out to be this part. Okay, so the solution of this difference equation is, if you just integrate the both side, and you will get x square plus ex divided by y is equal to constant. This is the solution of this differential equation. Okay, it's the general solution. Okay. Okay, so this says that the correct option is, the second option is correct. Okay, so let's move to the next problem. Okay, again, differential equation is given. So this is our differential equation, and we have to find the integrating factor. Okay. So notice that this differential equation is a linear differential equation. Okay. Let's call it as equation 1. One is a linear differential equation. Okay. And for a linear equation, the integrating factor can be find out. What is the integrating factor? You have to integrate and take the exponential of the integral of the coefficient of y. So what is the coefficient of y? So this is this coefficient of y, x over x square plus 1. So this is our integrating factor in this case. Okay, so if you so what we will do, divide by half and multiply by 2 here. Okay, so the whole thing can be written as d of log of x square plus 1. Okay, so if you find if differential of log of x square plus 1, then you will get exactly 2x divided by x square plus 1. Okay, so that means the integrating factor is half log of x square plus 1. That is exactly equal to under root of x square plus 1. Why? Because by properties of this logarithm and differential, this is just x square plus 1 to the power half, right? And then exponential and logarithm are inverse functions of each other. So it's the integrating factor is square root of x square plus 1. So the here correct option is A. Okay, so let's move to the last problem. So the 10th problem is the last problem of this live session. And we have to find the general solution of the given differential equation. This is our given differential equation. Okay, so differential equation is 1 plus y square plus x minus e to the power tan inverse y dy by dx is equal to 0. Okay. Okay, so what is dy by dx here? The dy by dx is minus of y square plus 1 divided by x minus e to the power 10 inverse y. Okay, so instead of dy by dx, let's see the differential equation dx over dy. So we will treat x as independent variable and depending on the independent variable y. In this case, we can write this e to the power 10 inverse y minus x and divided by y square plus 1. Okay, so why we are writing this it in this form? So that it becomes a linear differential equation. And how does this becomes a linear differential equation? Just take the this term here, 1 over y square plus 1 into x is equal to e to the power 10 inverse y divided by y square plus 1. Okay, so you can see that this is a linear differential equation because here all the derivative of different dependent variables appears with degree 1. Okay, it means let's call this the differential equation 1. We can say that the 1 is a linear differential equation and to solve the linear differential equation we have to find its integrating factor. Okay, so what is the integrating factor of a linear differential equation? We have discussed this earlier. So to find the integrating factor, that if you have to take the exponential of the integral of the so coefficient of x. So what is the coefficient of this? Is 1 over y square plus 1 and you have to integrate this with respect to y. Okay. So this is the integrating factor and this turns out to be e to the power 10 inverse y, right? Because the integral of 1 over y square plus 1 is 10 inverse y. So this is our integrating factor. And then solution of this equation is given by x times the integrating factor, which is e to the power 10 inverse y, which is equal to multiply e to the power multiply the right hand side of the equation 1 by e to the power 10 inverse y and then integrate integral e to the power 10 inverse y whole square and divide by y square plus dy plus constant. So this is the general solution of the integral our differential equation, but we have to integrate this integral. Okay, so what is that integral? Let's make a change of variable. Okay, so what change of variable we can do here? Just put 10 inverse y as a new variable t. Let's call it t. Okay, that means the 1 over y square plus 1 dy will become dt. Okay, so this change of variable we do here to find out this integral. Okay, so if you do that, then so let's integrate here. So 10 inverse y is t. So e to the power t whole square, which is e to the power 2t, and then dt, and that will just become half of e to the power 2t. So this is the integral. So the final solution, the general solution, in this case is given by x e to the power 10 inverse y is equal to, now because we have already integrated this term and which is turns out to be half of e to the power 2t where t is 10 inverse y, this is equal to half of e to the power 10 inverse y whole square plus constant. Okay, so this, so which option is correct? So x e to the power 10 inverse y, and then we have e to the power 10 inverse y whole square divided by 2. So correct option here is B. Okay, where C is our integrating constant. Okay, so we have discussed all the 10 problem of this live session, and Thank you everyone for joining.